Hi, my name's Tim Hall. I'm a chartered engineer, as you can see by the certificates that I've got on the wall here. This shows that I'm a member of the UK Institute of Electrical Engineers, and I'm shooting this video to try and convince a company in China called SureElectronics that there's a problem with a colour sensor module that I bought from eBay. I've got on the laptop here the manual for it, which I've been using to explain to me how to hook this thing up. Here's the module. I've got it connected via a piece of ribbon cable here to a Arduino shield, which is actually a display shield. I've got the relevant wires that I need connected and the ones that I'm not using taped up to stop them from shorting out. So I'll just go through the connections that I've got here. I've got the chip select wire there going on to pin 10 of the Arduino. The SDI connection, that's the SDI of the colour sensor, not of the Arduino, so that's actually an output. That goes to pin 11. Then I've got the SDO, which is the output from the Arduino, going on to pin 12, and then the clock connection onto pin 13. I've also got a ground connection there onto pin 14 of the Arduino shield. On the other side I've got a ground connection. I've got two ground connections and VCC to provide the supply to the colour sensor module. So here's my Arduino. This is currently running one of the example Arduino programs that I've downloaded to it, which all it does is to just blink the LED every second, turn it on and then turn it off, and that LED is attached to pin 13 of the Arduino chip. That's hooked up to my laptop via a USB cable, so I'm able to send programs to it. Currently this is the program that's running, which is a very simple program. All it does is to turn on the LED, defining the pin 13 as an output, turns on the LED, delays for 1000 milliseconds, and then turns the LED off again and delays for another 1000 milliseconds, which results in this blinking that you see here. So for the benefit of this exercise, what I'll do is I'll first of all disconnect the Arduino. I'll attach my display shield, plug it back in again, and I'll also provide it with some 9 volts power, because the USB isn't really man enough to be able to provide power for both the Arduino and the colour sensor. Okay, so what I'll now do is to upload the program for the colour sensor, which I've written. All this does, it's a very simple program. There's a library included at the top for the actual LCD colour module, there's the commands defined for the red, green and blue commands for the colour sensor, which I can show is the same as the documentation from SureElectronics. Skip through this. Okay, I maybe should have shown you this before. This is the actual pinout that I've used for the colour sensor module that I used to show what wires to connect to which pins on the Arduino board. Then there's a bit down here which describes the commands that you have to send for the red, green and blue sensed values, and what you should get back. If you look at this timing diagram, what you should get back is the actual values sensed. So the way I've interpreted that is, in my Arduino program I've got the constants defined for the commands, then I've got a character buffer, 16-byte character buffer for the display string for the display, then the red, green and blue return values, which I've initially set to just 127. Chip select pin is pin 10, as I described earlier. SDI pin is pin 11, SDO pin 12, and the clock is on pin 13. So the setup loop then, what that does is to initialize the LCD display, clear it, then set the pin modes on each of the Arduino pins, the chip select, SDI, SDO and the clock, define them to be inputs and outputs as appropriate. Then we go into this loop, which all that does is to set the chip select pin low, to send the command for the red and read back the value for red, same for green and the same for blue. Set the chip select pin high again and output those results to a string buffer, red, green and blue values. Send that to the LCD display and then repeat over and over again. There's a little subroutine used there called SDI-COM. That's the little subroutine that I've written to convert the bits into characters that can be sent on the SDI port. All that does is it sends a byte, as you can see, for C equals 0, less than 8, plus an increment each time through, to write a low value to the clock pin, to write the command with the appropriate mask for the particular bit that you're interested in, and then setting the clock pin back high again, and to rotate around that, shift that mask so each bit is rotated in turn. That sends the command and then receives back a byte again for C equals 0, C less than 8, and incrementing each time to write to the clock pin low. The result is left shifted one place and then ORed with the input from the digital read pin and return the result. So that's the program. It's currently not running at the moment because the Arduino is still running the test program that I sent earlier. So I'll now show that I can upload this program to the Arduino. Uploading to IO board. Done uploading, and as we can see there, the Arduino is now displaying the results. Coincidentally, these numbers correspond to the commands that were sent to the Arduino, or sent to the colour display, should I say. coloured sensor, and don't appear to reflect the actual sensed values that the colour sensor should be receiving. I've still got the lens cap on the colour sensor, but I can take that off and demonstrate that it makes no difference to the received values. Okay, so I hope that is enough information to convince the guys at SureElectronics that there is a problem with this module, and that they'll have no problem in sending me a new one.